Hi guys, welcome back. So what we're looking at today is 5.3. It's all in your head. So let's go ahead and jump right in. So congruent statements and corresponding parts. Remember that when you write a congruent statement, such as triangle ABC is congruent to triangle FGH, the corresponding parts of the two triangles must be the parts that are congruent. For instance, angle A must be congruent to angle F, side AB must be congruent to side FG, angle B must be congruent to angle G, and our side BC must be congruent to side GH. Also recall that the congruence patterns for triangles, angle, side, side, and side, side, are what we can use to justify triangle congruence. So the segments and angles in each problem below are corresponding parts of two congruent triangles. Make a sketch of the two triangles, then write a congruent statement for each pair of triangles represented. State the congruence pattern that justifies your statement. So we're going to look at these first two right here. So we have side ML is congruent to side ZJ. So I'm going to draw them over here, hopefully. Whoops, that's too thin to see. Okay, sorry about this. So we've got a side of our triangle and it's named ML. We have another triangle with a side named ZJ. So we just draw a side and label it in the order that it's given. So ML, ZJ, and make sure they're in the same corresponding parts. So Z is at the top, M is at the top. They're the ones that go together. Now we have another side that's LR is congruent to JB. So we go from the L and we're going to go over and make R. And then we're going to go to the J and we're going to go over and make B. There we have our other side. Now here it says angle L is congruent to angle J. So that just means this side and this side, or sorry, not side, those angles, so I made arc marks and I forgot to put my tick marks in, so I'm doing that right now, are congruent. So it means these angles are the same. Now, obviously we don't have a full triangle right now. So what we do is finish out the triangle. So now we have two triangles. So our congruent statement is triangle MLR is congruent to triangle ZJB. And its congruence pattern is side, angle, side. Because we have an angle in between two congruent sides that we also know is congruent. All right, the second one that we're looking at here, number 2. So I'm going to erase this drawing, so that way we have space for the other one. Okay, so we've got side WB is congruent to side QR. So WB is congruent to QR. Put our single tick mark on there. Tick marks show what sides are congruent, so because they each have a single tick mark, we know they're congruent to one another. Now we have side BP is congruent to side RS. So B extended out, get P, R extended out, S. And then last but not least, WP is congruent to QS. So WP is congruent to QS. So notice WP and QS have 3 tick marks because they're the third side that's congruent in here. There's 2 tick marks on BP and RS. It shows they're congruent. So we use however many tick marks we need to show those congruencies. So for our congruent statement, well, we have triangle WBP is congruent to triangle QRS. Now, there are different ways that we could do this congruent statement. This is just one. I'm just starting with the first one up here and going around. We could do BPW, we could do PWB, We could do PBW. We could do BWP. It doesn't matter what order you write the first one in, so long as the second one is wrote in the exact same order. So that's what you have to make sure of. You have to make sure these same parts are in the same order between the two of them. And so then looking at angle, side, or side, side, what is its congruence pattern? Well, we know all three sides are congruent, so it's side, side, side. All right. Our next section, we've got some special triangle segments and proof. So recall the following definitions. So in a triangle, an altitude is a line segment drawn from a vertex, so vertex, perpendicular to the opposite side or the extension of the opposite side, depending on what it looks like. So remember, perpendicular means it's intersecting at a right angle. A median is a line segment drawn from a vertex to the midpoint of the opposite side. So this one, it's going to go right in the middle, so it's not necessarily intersecting at a right angle. And then these two pieces, like you can see, are going to be congruent to each other. An angle bisector is a line segment or ray drawn from a vertex that cuts the angle in half. So here we have our triangle. We're cutting this angle in half, so that means each of these angles on either side of the dashed line are the same degree because it cut that angle perfectly in half. And last but not least, a perpendicular bisector of a side is a line drawn perpendicular to a side of the triangle through its midpoint. I know that sounds confusing, but it's just a line drawn perpendicular to the side of the triangle through its midpoint. So notice this is the midpoint. We have a line drawn perpendicular through it to get to the other side. All right, so we have a triangle here, and we're going to take and name segments that are these different parts of the triangle. So special triangles is your key word for this lesson. Special triangles is your key word for this lesson. So for number 7, it wants us to name a segment in triangle GHM. So GHM, the whole triangle. That is an altitude. So remember, it says altitude is drawn from the vertex perpendicular to the opposite side. So where do we see one of those where it's going from the vertex to being perpendicular to the opposite side? Well, there's two choices here. So this one's a little weird because in this one we have it splitting. In this one, it's not the case. Here, it's GH or it's MH. It's the only place where a line goes from the vertex to the opposite side at a perpendicular, being perpendicular. So GH or MH. Those are our two. All right, name a segment in GHM that is an angle bisector, so cutting the angle in half. What line would that be? What line segment? It would be GE. It's cutting this angle right here in two. All right, so you're going to find a line segment that is not an altitude in GHM, and then you're going to create a perpendicular bisector. All right, and you'll name the one that is currently the perpendicular bisector. All right, use triangle DEF in problems 11 through 13. So we want to construct the altitude from vertex D to side EF. So from vertex D to side EF. Now, to go at a perpendicular angle, we can't go in sides. This one's a little weird. We're actually going to extend out this side, and then we can draw. Mine is not going to be perfect, as you know. Trying to draw on the computer is not the easiest, but yours will be a lot better. So you want to make sure that you get a nice perpendicular angle here, coming straight down and extending to the outside. So sometimes our altitudes can be on the outside. So we have the line segment DH. All right, 13, construct the perpendicular bisector of EF. So we find where the middle of EF is, which would be right about there. You can also measure it to make sure. And then we need it to take and cut through the other side at a right angle. So there's our right angle. There we are. There's our perpendicular bisector. All right, so here is our proof, our very first proof that we're really going to look at. Tehani has been studying the figure below. She knows that quadrilateral ADEG is a rectangle and that ED bisects BC. She's wondering if, with that information, she can prove triangle BGE is congruent to triangle EDC. She starts to organize her thinking by writing what she knows and the reasons she knows it. So she says, I know ED bisects BC. So we have all this information. So that she knows that BE is congruent to EC by definition of bisect. I know that GE must be parallel to AD because the opposite sides in a rectangle are parallel. I know that GA is parallel to ED because they are opposite sides in a rectangle. I know that AD is contained in AC, so AC is parallel to GE. I know that GA is contained in BA, so GA is parallel to BE. Obviously, she's got lots of information that she knows from this with her reasonings. It's just not very organized. So what we're going to take and do is we're going to use the I know statements and her reasons to write a 2-column proof that proves that triangle BGE is congruent to triangle EDC. So we begin our proof with the givens. We're always going to begin our proof with givens. So whatever's given to you, that's always what you start with in a proof. So those are already done for us. Triangle ADEG is a rectangle and ED bisects AC. So this is what a 2-column proof looks like. You write your given statements, you write proof, then you have your 2 columns, statements and reasons. You list out your givens, reason, given. Now, this is a 7-part proof. So we're going to have 7 statements on this. I'm going to zoom this in a bit. So for statement 3. So currently, we have talk about the rectangle, to talk about ED bisects BC because we were given that. Well, what does she know else because of the fact that they bisect? She knows BE is congruent to EC by definition of bisect. So come down here. BE is congruent to EC. Definition of bisector. So definitions, theorems, postulates, these are all different things that we can take and use to prove or to give reason in a proof. Those are all different definitions. So saying that BE is congruent to EC. So this here. So knowing that it's being bisected, that ED bisects BC, and we know because of bisect that it's cutting it in half. So that's how we know those 2 parts are congruent. So the next thing she starts talking about is the parallel. So she's saying that GE must be parallel to AD, GE parallel to AD, because opposite sides are parallel in a rectangle. She also knows GA and ED are parallel because they're opposite sides in a rectangle. So parallel we notate with arrows. So that's the next part of our proof. So step 4, we're saying that AC is parallel to GE and GA is parallel to BE. P.